right? So you're teaching it to recognize patterns, and then you ask it, I need you to complete text based upon my prompt. So your prompt is a starting point. Your prompt is a starting point into the neural network. And then it will complete your prompt. Is that, well, thank you for the prompt. I know now I know where to start in a neural network, and then I'll complete it. Excuse me. Oops. Okay. So it steers, the prompt steer the behavior of the language model. No, it doesn't change the weights in the neural network, right? If we go back to that diagram of the neural network, each one of those boxes, and that for a large neural network, there could be billions of those boxes. There's probability weights in there. I'm telling you what's the most likely thing with a set of probabilities. And the language model picks a random number and says, if it's between this and this number, go that way. If it's not between this number and that number, go that way. So it's a collection of probability. It's a cloud. It's a probability. What is it really called? Probability distribution cloud. Not cloud in the Amazon type sense, but it's a collection of probability distributions. So you're steering the behavior of the model by giving it a prompt. Say, no, go. I want you to go this way. So your token is in your prompt. In other words, your prompt is very influential in giving you what you want. So the better your prompt is, the better the output. The better your prompt is, the better the output. And that this is the reason why, because you're guiding the language model. I want you to go this way. And by putting more appropriate text in your prompt, you're sort of helping it go that direction. So prompts are very, very, what you put in the prompt is very, very important. And it turns out that, let me hold on to that. Let me cover prompt techniques. So there's this term called prompt engineering, which is a very silly term because it's not really engineering. It's just techniques, prompt techniques. I guess some people still call it prompt engineering, but it's not even close to engineering. So they're prompt techniques. But if someone says it's not prompt engineering, just to be polite, say, oh yeah, I know what you're talking about, but it's prompt techniques, right? So when you build a prompt, you start simple, and you kind of over time you kind of like add more things to it. That's the way you kind of construct a good prompt, and you should be very specific and precise. And it turns out, maybe not oddly enough, but the best prompt writers are teachers. Quite naturally, right? When you're teaching someone, you have to be very precise, very specific, give examples, right? And so you have to be very accurate. That's what you have to do as a prompt writer. You have to be almost like you're a teacher. You're teaching something, right? And you have to give plenty of examples. And of course, there's the size of your buffer that you send to the language model is called a context window. Basically, that's the size of the data. That's the maximum size of the data. You know, for small models, it could be like 32K. For large models, it could be like Gemini Pro is like two megabytes. So you can send chunks of data every time you talk to Gemini Pro. Of course, when you think about it, well, if I'm sending that back and forth all the time, that's a lot of data. So 2 megabytes back and forth with a chatbot, it's like, okay, well, maybe I don't want to do that because that's going to be very, very expensive. And this last one here, don't dwell on what not to do. It turns out the language models are really, really bad at negation. They don't really understand when you say, don't do this, don't say this, or don't do that, don't say it this way. They don't understand that. There's a paper. I'm not sure if one of these links in here it does that, but if you want, I could find that paper. It's language models are really bad at negation. So don't tell it what not to do. Just focus on what it should be doing. Right. So here's a few techniques. The zero shot is just very simply, I'm sort of hope for the best. I'm saying explain generative AI, and it's going to give you something, right? So there's hardly any context in that query. I guess you call it a query, that little prompt there. So that's called a zero shot. A few shot is that, okay, I'm going to give you some examples. I'm going to give you some examples, and then I'm going to ask you something. So this example is that here's a rating system. If someone says it's a fantastic product, say that's a 10 and it's very positive. If someone says no one responded, say it's a 0, very negative. So you're giving it examples, and then the last one says, well, if someone says still waiting for a product for 6 weeks, how should you rate that? So here I gave it 4 examples, but you can see like in a production system, I can get this data from a spreadsheet from like hundreds of users. And so I have a database of what my users are saying. And then I said, well, this person said something that's not quite there, but how would you say they rated that? And based upon the patterns in that data, the language model could potentially say, well, it was a 2 negative. So here I'm giving it some examples. So a few shot. Okay. And there's like, a dozen or 2 type of techniques, but I just want to cover these 3 since they're very popular. So this one's important, chain of thought. So chain of thought is that when a human solves a problem, there's problems and there's subproblems. So you have to solve the subproblems. So here I'm giving it a series of steps. Here's how you solve the problems and subproblems. And I'm just giving it, question and answer. But I could give it many of these. Here's a question, here's a solution to it, right? So I give it a whole bunch of them. Here's a new question. I want you to follow my chain of thought, how I solved the problem before, and I want you to give me the answer. So this is called chain of thought. And interestingly enough, chain of thought in language models was another patent from Google. And actually even chatbots are patented by Google. That's just an interesting aside. But so chain of thought is you're giving it how you think through a problem. And it turns out that language models follow this really well because there are patterns, right? That's language models, AI in general or I should say machine learning in general is really good at patterns. So here are patterns, and I want you to give me the answer based on the patterns. So chain of thought is actually quite powerful. As a matter of fact, it's so powerful that more recent models, like the DeepSeek model, are called reasoning models. So a reasoning model is another way of saying this uses chain of thought. So there's some in some of the OpenAI, actually even Google has a reasoning model now. So the reasoning models are language models that use chain of thought internally. So you don't have to put chain of thought into your prompt. It comes inherently in that model. Now, chain of thought is not always good for all applications, right? It's not good for all types of AI. So traditional language models, the standard, few shot or 0 shot, where you're putting context into the prompt. There's those type of models. The newer reasoning models, you don't have to tell it how to think because it already knows how to do chain of thought. And there's other advantages to some of these more modern reasoning models, but that's one of the big ones, is that you don't have to tell it how to think. So here's an interesting thing. If you're using one language model, let's say you're using a standard OpenAI or Anthropic language model, and then you're switching to a reasoning model, your prompts may not work the same way. Your prompts may not work the same way. What I mean by that is that the same prompt may give you wildly different answers. So here's like, this is how IT has to evolve. Like we're so used to determinism. The old days, if we're testing a query in a database, okay, we know that we give it the same query, we can get the same output. It's the same query, same output, right? Maybe it's faster or slower, but same input, same output. It's different now. We're now probabilistic IT, right? So we have to be really careful. Meaning companies have to be very careful on how we deploy this stuff. Because you may deploy something that uses language model, and someone says, "Let's use one of the new reasoning models," and you turn on, one of the reasoning models as opposed to the traditional models, and you get different answers, with the same user input for end user. So you got to be really careful. You have to constantly monitor this stuff. That's why putting this stuff into production is not easy. Okay. So, and then when you generate a prompt, the typical structure is that your prompt has some context, like, here's my chain of thought, or here are some examples. Here's some data from the web that I got. So that's my context. And then here's your request. Like, I want you to tell me when the Miami Jug meets. Where does the Miami Jug meet? That's my actual prompt. And then you say, like, I want the answer in JSON format, or I want it in French, right? Or whatever output you want it. So that's the basic structure of a prompt. Now, if you're using a reasoning model, which they're starting, more and more, they're starting to come out. I mean, DeepSeek, I think, was a little bit of a kick in the pants for some companies. Like, okay, well, maybe we should start focusing on reasoning models, because they solve harder problems. They don't get rid of the older type of language models. They're more powerful, potentially slower, a model, but it solves bigger problems. Like, you're not going to use a reasoning model to do summarization. I want you to summarize this text and give me the paragraph description of it. I probably wouldn't use a reasoning model for that. That's too overkill. So you have to choose what type of model you want. So just to reiterate, when you a neural network, and that's the reason why I do this, because when you actually use this stuff, in the back of your mind, say, like, oh, well, that's how a neural network works. So now I can craft my prompt a certain way, or I know how to feed data to it to make it go in a certain direction. So when you have a neural network, let's say it's this massive data structure, and there's random numbers. The way you get started, you put random numbers in the neural network. Not zeros, because zero is a legitimate probability. So you put random numbers in there, and then over time you say, here's some text, and you can feed in the text, and the ones that are darker, the brighter green, are the more probable. They have higher probabilities, and you keep on feeding this until you've trained the model, right? You're satisfied with training. So then this cloud is inside there are the possible paths that a language model can take to give you a completion, right? So it gives you, maybe that's one possibility. Another one might go a little bit higher, a little lower. It's like the European model says the storm's going this way, and then the US model says basically it's a probability cloud, right? Now, if you give it more context, right? So not only do you give it prompt, but you give it additional text. You say, okay, I'm going to go to the Miami Jug's website or a meetup page. I'm going to pull out the about text. I'm going to put the about text in there, and give me more information about. So you're giving it more context. Like, if I were to ask the language model, how often the New York JavaSig meets, it might guess. It might say, oh, it's once a month, or you should check with the website. Last time I tried this, it says, you should check with the website. Now, if I went to the website and I pulled out the about for our user group and took that text and put it in as part of my prompt, then we'll give you a better answer. So the better your context in your prompt, this is really important. The better your context along with your prompt, the better your results. And that could be quite large, right? You might think, like, well, I'm just going to put a paragraph or two. So when I was at Google, we actually put whole books, entire books were part of the context. Entire books were part of the context. And there's diminishing returns too. So there are, like, Gemini Pro has 2 MB context windows. That's a humongous context window. So that's why we were stuffing books in there. But it turns out that language models, just like humans, forget what was said earlier in the conversation. So it's yet to be determined what is the optimal context window for a language model. I mean, I think that's research is still happening. Some people say, like, I need a big context window, but in practice, I think there was a paper, I think from Stanford, saying that a large context window is not the answer. But it's a beta. We're still figuring that out. Okay. So the better your context, the better your prompt. So this is critically important. And this is critically important. Context influences how the language model completes your prompt. This is really, really important. The more appropriate your context, the better your response. So I want you to understand this is really, really important. So you can add context manually, of course. I copy paste. Let me copy the, this text here, and then I'll put that in the prompt, and then I'm going to ask my question or my real prompt. I could do that manually, or I can write a Java program. Okay, before I send it off to the language model, I'm going to incorporate a file. Right, here's a file, all about my Java user group, and it's it's a 10K file. I'm going to stick it in there every time, so I can do it programmatically, right? So I can do it manually, cut and copy paste. I can do it programmatically, just add a file, or a file or some data from someplace else, or there's another way. And here, say, any suggestions? Well, there's a third way. There's something called RAG, Retrieval Augmented Generation. And probably the only thing that came out of Facebook, anything good that came out of Facebook. So RAG came out of Facebook research. You might question what kind of research would Facebook be doing, but that's another discussion. So RAG came out of Facebook research. And what RAG is, if you go back to the prior slide, it's adding context programmatically. So instead of just like stuffing a file there, in a blanket file, let's do something that's a tweak on that, right? Because remember, context is critically important. So here's RAG. So if you look at the top, we have, excuse me one second. If you look at the top, we have the prompt, right? This is a standard thing. We have prompt, we send it off to the language model completion. Okay, that's the thing that we know and love, right? It's really easy to do. But now we want to put context into the prompt. And instead of just putting in a file of stuff, because part of that file could be relevant information, or part of the file could be useless information, but we're just blanketly putting a file in there. Wouldn't it be nicer if we put only related context? All right, maybe that would work. We need to find the best context for my prompt, not just a blanket file, which may or may not contain information, valuable information. Let's do something a little more clever. So let's save stuff into a database. I'm just using a vector database, but just say some database, vector database, a graph database, there's some data store, and it has all kinds of useful information in there. And what I want to do is I want to go into that database, pull out relevant information to what the user asked, the original prompt, and pull out things that are similar to that. Give me that text, and I'm going to take that text, glom it together with the user prompt, and send the whole thing to language model. So a RAG is a tweak. What I said before, instead of sending a dumb file, right? It's kind of like a very, very gross way of doing it. Let's do something a little more clever. Let's pull out relevant data out of a data store. Okay, it's commonly a vector database, but sometimes it's a graph database, but it's someplace else, right? Stored. Actually, here we're using traditional IT along with probabilistic IT, right? We're using LLMs, which is probabilistic IT, and now we're using traditional IT database lookup. So here we're combining probabilistic IT and deterministic IT to come up with a cool answer, right? So the prompt gets sent to the vector database. Actually, not get sent, but the prompt is looked at by some code here. So like I want to find the most relevant bits of text in my database that are similar to the prompt. And it goes through the vector database and finds similar text using something called embeddings, which topic for another discussion. But basically, it's looking for the most similar text in the database. And that database was in a separate phase. It was full of text and stuff in the web, PDFs, maybe MP3 transcriptions of, YouTube transcriptions, all kinds of good stuff. it was torn apart into chunks, stored in the vector database, and you're looking for similar data. Give me the top 5 or the top 10 that are most similar. Take those, stick it together with the prompt, then send it to a language model. Then you get a better completion. So that's what basic RAG is. Now, basic RAG has been around for like, a year plus. There's been a lot of advancements to RAG technology, but this is the basic RAG architecture. All the modern RAGs, there's like, different techniques, there's like a dozen different ways of doing this. They're all riffs off of this. Once you understand this, any of the advanced RAG architecture is just a riff off of this. Okay, so what's the advantages of doing this? Well, you get better completions. And you get reduced hallucinations. So hallucination is that it followed the language model followed a path through the neural network that was probabilistic, and it didn't give you the right answer. It just went that way when it should have went that way. So hallucination is that the model thinks it's really accurate when it took a left turn when it should have taken a right turn. I mean, the proper term for it is not hallucination. They're called confabulations. That's the proper term, but the average press says hallucinations because it sounds better. It sounds like, it's like a human is doing it, but the proper term is called confabulation. So and then you have full control of the database, right? For the big companies only update their language models like every 9 months or a year. But if you have the database, you're in control of it. It could be up to date in real time, right? It can be totally up to date in real time. You're in full control. If you don't want to do that, you want to do it like on a weekly basis, then it's weekly. But it's up to you. Okay, so that's a benefit of RAG. Now, as a senior manager in a company, there are a lot of things to worry about when you implement a RAG architecture. So, if you're a junior programmer, you show your boss this. It's like, I'm going to do this, and great, okay. And then you hit all these questions. It's like, it's not that easy to implement this stuff. There's all these different questions. Well, I have different prompts. I need to version prompts, right? Just like anything else, any other software thing. It has to be versioned. You can't just like, well, the prompt worked last week. Okay, what was it? I don't know. We just changed it. So no, you have to version it, right? Is it a vector database? Is it a graph database? What type of embedding are you using? Where's the security? Where's my legal department? How do I audit this? There's all these questions you got to deal with. So putting it into production is not a piece of cake. Right? It's not a piece of cake. So these are all things you have to worry about. And if it's risky, because this is a probabilistic system, if you're thinking that you can develop a system, and if there's a possibility that a wrong answer will hurt your company, then you have to start thinking seriously, maybe we don't use generative AI. Maybe we use something else. So it's not the answer to everything. You have to, there's like any other IT thing, you have to figure out, okay, where are all the problem areas? Where's my, where are my pain points?